1, 2, NoSQL and the big data. 651, 652. Only 1, no, 2, 3. Okay. Right now I'm discussing with the department whether we are going to offer the big data, the concentration in computer science department, which means as I discussed with the registrar's, the concentration program is not appeared on diploma. Diploma only show the name of your degree, right? But your transcript can show the concentration program, like this student, the complete the requirement of the big data, concentration, something like that. Do you guys want such a thing? Do you think that will be helpful?
Yes.
So even though that is not appeared on the diploma, because diploma only show the program name, your major, okay? So, but even though it is appeared on your transcript, that will be helpful for your the job searching or the future. So if so right now what I'm thinking is those who complete the 651, which is the big data, 652 is NoSQL database, and this course definitely the database is most of the computer science student already completed. So if the student completes the 4 courses, so we'd write over the concentration or certificate on the big data and data analytics, something like that. So from this semester, which means that if you are graduating this semester, it will be you can, but you need to submit some of the form to request such a concentration. I'm not sure whether it can be concentration or certificate. I need to discuss more with the department. Okay. Anyway, so I'm thinking then, which means every year I'd like to offer at least one time of the NoSQL, the big data, and data mining course. So once a year. Okay. So by the way, do you think how we can make the computer train or educate? How can we do that? Just without knowledge of data mining. So we are thinking about the data mining technique or knowledge discovery or the intelligent system, but which means we try to make the computer more intelligent, which means we need to train, we need to educate the computer. How can we make that?
Artificial intelligence and neural networks.
Yeah, that is one of the way. But in general, just without knowledge of such an algorithm, just think about, in general, how can we educate? How can we train?
Just give them rules.
Give the rules. That's one way. Rules. So you can use the if, then, else. Okay? So in other words, it can be considered as the event, condition, and act. So if something happens and apply the rule, then do something. The main problem, when you educate, when you raise your kids, you probably realize that you need to do this one, you need to do this one, you should not do this. So every time you need to teach your children is sick and tired. You cannot teach all the cases. You expect your child realize, okay, he or she can do this one, or he can not do this one, right? So rule-based, that's one of the approach, but it's not, there's a pros and cons. So if we have the nice rule or general rule, okay, it can be applied. However, so sometimes such a rule can be changed. So that is the drawback. Any others? How to classify?
Like we give general case based on the general detection. So that is used SVM like a training. So
Then how can we train the computer? It's just a very high level question, not details or technical question.
Give them correct like answers or
Give the correct answer.
yeah, so they
Okay.
can learn.
Then learn what? Yes,
Give them some patterns. So
patterns.
Yeah.
That's
so
good.
That you can recognize.
Answer. So if computer can recognize certain pattern, then it can make the rules. Okay. Then what did you say before?
Make them learn like
Learning.
rules and
Rules. After that, just before she answered the pattern, you said something? Never mind. Anyway, so pattern, that's good answer. So the problem is, how can computer find the pattern? Actually, most of the technique that we are going to discuss in this class, or the most of the data mining, artificial intelligence, neural network, whatever that is, it's based on finding pattern. If we can find the pattern, that's it. That's done. That is the reason we have another class, pattern recognition, that focus on pattern finding. It's almost the sibling of the data mining technique, not much different. So pattern. The problem is, how can you find the pattern?
You need a rule and concepts. Rule and concept to follow this.
That is actually the same thing. The
Yeah.
rule or concept or pattern. It's the same thing. The problem is, how can we find them?
the ground truth or correct answer. You give them-
So you said the training
yeah.
before, right? Then how can we train the computer? Think about the when you were trained when you were 3 years old, 4 years old by your mother. Probably your mom, or in case of me, my mom said that this is an apple. She showed me, okay? And explained first time. Round thing you can eat, usually it's a red color, but sometimes a blue color. Then I forgot. Then a couple of days later, she bought again and explained. And the time goes on, I realized this one is the apple. Even though that is not exactly same as the dictionary definition, but I have my own definition. I have recognition on that object, apple. So even though I never seen this apple before, I can decide that this is the apple. I can eat it. I can make the juice. Okay, that is the training. That is kind of pattern recognition. How can we do that?
I given them, telling them that.
If I'm genius, I can know everything, but mostly
Indicate.
repeat it. Then, if you are smart, you don't have to learn every time 100 times. Within a couple of times you can do that, but some of the students are stupid, so we trained many times. Anyway, repeat it. So it's kind of frequency. Okay, if something happens a lot, okay, computer realize this is a pattern. This is something characteristic of data or event. Actually, any of that in the data mining technique is based on such a basic concept. Computer is not like the human being. Even though human being use such a frequent pattern to realize, it's kind of generalization and specialization processing, but there might be plus alpha for human being, okay? Like the creativity and inference. So still it's investigated, but nobody knows what's going on inside the brain. However, computer itself is not that smart. It's not smarter than the human being, human brain. So can your computer or laptop actually be creative? No. Unless you provide the programming or the application, no, your computer cannot do anything. So actually such a technique that we are going to discuss is based on the repeat, how many times repeated. If frequently happen, that is the rule, that is the concept, that is the pattern, then computer can use that. any of the application, artificial intelligence or the neural networks or the pattern mining, the data mining, is based on the such a frequency, how often. Okay? So this the kind of pre-processing is the same thing. If we classify this one, it's a frequently happen the such a low they are similar. Similar means the such a data level of data is a frequently happen in this. If we consider 100 to this group, no, it's not frequently happen the data. So we can consider that is an outlier something. So when you think about something, the data mining technique or artificial intelligence, do not exaggerate what computer can do. There might be limitation. Even though the CNN or Fox TV or CBS News, they sometimes show the very fantastic the application or tool that can provide future of. But anyway, our data mining artificial intelligence level in terms of human age is around 3 years old or 4 years old. Okay, it's just based on the repetition. Okay, how many times repeated? As you train your kid, 3 years old or 4 years old. Then keep your mind, our technique that we are going to discuss this semester is only 3 years, 4 years old level. It's not very complicated. So if something happens frequently, that is rule, that is the positive, that is the pattern, that is our concept. When we are saying the something concept, it's not like the concept in your mind. Okay, that is a limitation. That is the something domain we can discuss. So first one is as name implied. It's a chapter 6 in our the third edition, but in the previous edition is chapter 5. The chapter 6 in new edition, but in new edition chapter 5 divided into 2 parts. So the chapter 7 is the advanced part, but we are mostly discuss about the chapter 6. So that is the frequent pattern. If something happens, the frequently, that is a rule, that is a concept, that is a pattern. So, but at that time we consider some association between among the data item, how much related. So we try to focus on that. So each data mining technique focus on the different aspect, but most of them are in general, in broad view, it's based on frequency, frequent, repeated, how many times repeated. So we try to focus on such association and correlation of the data. Okay, one of the naive example is the Walmart. So I think that I probably introduced the beginning of this class. So when you shop, okay, in the Walmart, so if you purchase the bread, probably you can purchase the milk also. So if you purchase the bagel, so you try to purchase the cheese, okay? Then at that time, you do better put next to each other. It's like the next to the baby, the shop, there might be the liquor store also. Because many of the young parents, they drink a lot and they need the baby stuff, something like that. So that is a frequent mining. How can they find such a rule? From they analyze the receipt, transaction. So for each transaction, if there exists the Superman who can intuitively realize tens of the 100 millions of the transaction, how many items in Walmart store? It's more than 10,000, okay? 100,000 different items. So it's not actually possible to realize which item is related to this one, whether they have the pattern associated or correlated or not. At that time, so we try to develop the something algorithm to find such a frequency. The frequently happen the data item. So frequent happen is a pattern occur the same frequently in the data set. Okay? So we can say the most of the data mining technique are based on the kind of frequent pattern. Okay? The clustering is the same classification decision tree that we are going to see the last of the semester. Most of that, if something, then at the time, one more thing is we need to sometimes classify based on the rule, based on the pattern that we find. If there's a new data, we try to guess whether this new data belongs to here or here. That is also based on the frequent pattern. Okay, then you do better remember the name of this guy, Agrawal. Okay, very very popular and the most popular person in data mining and database research. Mostly also cited. He published a paper, mostly cited. Okay, I forgot his first name. It begins with S. Anyway, if you type the Agrawal in the Google, he's the first one guy. Okay, he was in the Microsoft and also he was in the Bell Lab and IBM. The research in Armada is the white plane. Also, he was in the Microsoft. Recently, he founded his own lab with the data insight or something like that. And but he's you can see it. Even recently, most of the well-known paper. So his name is one of them. His the colleague or the student or when they publish the paper works with the Agrawal. Then he and his colleague proposed the first time the frequent item set and the association rule mining to address the problem of the market, the basket problem. So whether is there any pattern to purchase the item in the market. So it's called the market, the basket problem. So to do that, idea is so simple. If there exist items that happen frequently, okay, we try to consider such a item as a kind of rule. Okay, so that can be used a lot. So like not only the shopping mall, like the basket data, the market basket data analysis is used for the cross marketing. Cross marketing means if somebody purchased this one, okay, and suggest the another one, okay, it's used a lot in the banking system. If the it's called the CRM, customer relationship management system. So if you have a lot of the banking transactions, they already analyze. Then when you see the banker or the private banker, then the system pop up. Why don't you suggest that this the new product or the credit card service or something like that? Then it's called the cross marketing and web log analysis. So just like as if you are purchasing the item in the market, when you click this web page, what is the next one and next one? Okay. Also nowadays, so it can be used for the sequence analysis. If the DNA sequence is based on the consists of the ACGP, okay, then if AC happen, then probably the G and the A is happen together, something like that. So you can find such a frequent pattern using the frequent pattern analysis. Okay. So I already mentioned there's such a importance of the frequent pattern mining. It can be used for most of the data analytics. That is the best way. If you had totally different idea also is which is better than the frequent mining, I believe you will be the richest person in the world. Okay? For the computer. Okay? For the computer, so it's not the frequency based, but something other. Somebody would like to use the new neuroscience. So whether the investigating how the neuron in your brain is working to remember and process the data and infer the data, they'd like to get such an idea to the data mining and AI system. But I don't see any practical result yet from that. Okay, so it can be used for most of them. Okay, so we will see all of this in the following the chapter. Among them, I like the cluster analysis. So we will see mostly classification and the cluster analysis. Cluster analysis do not have the labeled data. Without labeled data, we can make the group. Okay. On the other hand, the classification usually use the labeled data and train. Based on training, we can decide which group the data item belongs. So first, the frequent pattern. So to do that, we are going to use this simple transaction data set. So each transaction has the ID and number of items. For example, the transaction 10 has purchased the beer, nut, and diaper. Okay, order is not important. We do not consider any order like the diaper, beer, nut. No difference. So we do not consider the order. And 20, beer, coffee, and diaper, and so on. For example, the 50, nut, coffee, diaper, egg, and milk. Okay? At that time, this is the item set, a set of one or more items. So, item set, beer, nut, diaper, this is the item set. Another item set is the transaction ID 20. This is the item set, item set, item set. At that time, K item set means K number of items. So, which means 2 item set is, this is a 3 item set. This is a 3, and this is a 5 item set. So, if we are saying the 1 item set is beer only, not only, diaper only, something like that. So, that is called a K item set. So, at that time, we have the 2 criteria. One is the support, and another one is the confidence. Support means how many times it's a frequent. How many times happen? For example, beer and nut. So what is the support of the beer and nut? Beer, nut?
One.
So just one. And what about beer and diaper?
3.
So beer, diaper, beer, diaper, beer, diaper.
4 die.
3. Okay. So at that time, the support is 3. Okay, 3 times happen. But such a absolute value of support is depends on number of transactions also. So if we can normalize or if we can consider probability. So for example, so 3 out of 5 transactions, which means 60%. or 0.6 in terms of probability. It doesn't matter. You can use the probability or relative, normalize. As long as it's a relative value, it's okay. So that is called the relative support, sometimes called S. Okay? For certain item set X. Okay? For example, what about the beer? One item set, beer. 1, 2, 3,
No, not 3 or
3.
3. So which means 60%. Okay. What about the nut, egg, milk, coffee? Nut, egg, milk, coffee.
2.
So 1. Okay. So only this one is a 20%, something like that. So that is a relative support. We are going to use such a relative support S or the probability of transaction contain X. At that time, so if this item set, it can be 1 item set, it can be 2 item set, it can be 3 item set, n number of items set, if that item set, the probability or relative support is bigger than, this time you will see a lot the name of this. Threshold. What is the threshold? Is it dictionary? Is it dictionary term? Some of the dictionary actually do not have the threshold. Okay. What is the threshold?
The
Maximum
capacity to set the
is
set line.
kind of
Constant.
cut off line. Okay. It can be considered as a maximum, usually minimum, lower bound. Okay. So if in this case, so if I show the some covariance, correlation. Sometimes we have the 500, sometimes we have the 4. Okay, at that time we don't know how strong correlated. It's so strong, it's not independent. It's a relative, related, but we don't know how much. At that time, how can we decide? Based on the knowledge, domain knowledge, or based on the experimental result, we can decide whether this one is related or not. That value can be represented as threshold. Okay, so that is called the minimum support. So if the item set X is equal or higher than minimum support, which means the threshold value, we can say that item is a frequently happen. For example, if mean support is 20%, beer, one item set beer is frequent or not?
Yeah.
It's a frequent. Okay, because the beer is 3 out of 5 is 60%. What if the minimum support is 50%? 50%. What about the beer and nut?
No.
Beer and nut is 20%. It's just 1/5. So 20% is below minimum support. At the time, we do not say this is a frequent. This is another big problem in many of the AI, data mining, machine learning. Sometimes, even though you have perfect implementation algorithm, depending on threshold value, output result can be different. Okay? In other words, threshold, even though it's mentioned the last line, even without any coloring, this threshold is very, very important. So when you, for example, I have a new idea, new algorithm for frequent the pattern mining or whatever, that requires certain threshold. But how can you prove? How can you find optimal number of threshold? That's a big problem. That's the same thing. One of my students, he works for the something social media data analysis, right? How can you cut off whether this is an important event or not? Just a half? That may be done. Many of the research use empirical result, which means test a lot. Then the human being decide this is definitely important. This may be important. So there, the average threshold value is roughly the 40%, something like that. And I'm the expert on this, so I know the result intuitively. So maybe beer and diaper should work together, and nut and egg also. Nut egg is 40%, so I guess it's around 30%, the minimum support, something like that. Okay, so deciding threshold is, why don't you keep your mind? Probably we do not discuss the details about how to design the optimal threshold value. There are a bunch of research actually to find automatically. Sometimes automatic is adjustable. Okay. Sometimes it's a the average value. Sometimes median value. Sometimes it's a normalized value. So anyway, it's very important, especially in multimedia data that I'm focusing on. So image and video data, they use a lot of threshold value. Because of that, if you are using such a data mining application or tool or processing, image processing, you may see something with the button or slide bar. You can adjust the result. Okay? Because that program do not know optimal value of threshold, so user can adjust, change. Okay? So to give the chance to the user to find optimal value. Okay. So that is a support and minimum support. However, that's not the all the thing. For example, let's see. Not this one. What about for example, the beer and diaper? So beer and diaper happen 3 out of 5. And also
4.
nut and egg happen
2 times.
2 times. Okay? But what if in case of the beer, okay? In case beer, how many times diaper are purchased?
2 times. 2 times.
3 out of 3 times. Right? Which means
100%.
it's 100%. So we can narrow down, if we narrow down the problem, for example, in case if one item is purchased, beer is purchased, how many times the diaper is purchased? 100 times. It's a very strong rule, right? So we can apply it right away. However, if we just consider beer and diaper in terms of support, it's only 60%. But if we narrow down how much, this is a support, as name implies, it's a support, first a support. Among that, the how much confidence is kind of conditional probability. In case of the beer, how many times? It's the 3 times, it's a 100%. However, what about in case of diaper? How many times?
3
Beer,
out of
1, 2, 3, 4,
75.
3 out of 4. It's a 75% confidence. It's still high, but it's less than diaper than beer than diaper. So in other words, all the people who purchase the beer must purchase diaper. However, among the people who purchase the diaper, only 75% will purchase. Then that is called the confidence. So confidence means there is a conditional probability of among the item. Okay? At that time, even confidence, we have the threshold value that is the minimum. That is called the minimum confidence. So for example, so we are going to use the 2 item set. Then the minimum support is a 50% and minimum confidence is a 50%. So we found the frequent pattern like the beer, nut, diaper, egg, and beer and diaper 3 at this time. So beer, then diaper. So how many times beer and diaper together? Both of them 60% support, but as we have seen, it's a 100% confidence for beer to diaper, or 75% diaper to beer. That's different, right? So those who purchase this one to purchase this, we are not sure whether the opposite direction is the same. So that, to address that one, the confidence can show the result. So we are going to use the 2 part. One is the support and is overall the probability, and that is a support, and confidence is a conditional probability. The problem is in case of we have the 100 item, how many different combinations? It's already here. So, can you remember that? This equation? It's a combination. 1 out of 100 plus 2 items out of 100. 3 out of 100 and up to 100 out of 100. If you sum up this one, why don't you remind the algebra? Before calculus, you probably learned the algebra. At the time you learned pre-calculus. I think the pre-calculus class, you learned the sum of this one is 2 to the power of n. Okay? 100 minus 1. That is how much? Too many. Okay? Too many items. Even this small, the transaction data set has many cases. Sometimes some of the students not easy to find number of count from the 3 or 4 item set. So main problem of the frequent data mining is too big to consider. Okay, so to address that problem, so we can consider two the variation of the item set. One is the closed, okay, closed frequent item set, and another one is a max pattern. So closed means, okay, let's see the example. So we have a transaction item set that has 100 the attribute 100 items. So first transaction include 1 through 100, all of them, and second transaction include 1 through 50. So minimum support is 1. So both of them can be considered as the frequent item set. At that time, closed item set means closed item set is there is no more there is no other sub. It's not easy to explain. Let's see. X is frequent, and there exists no super pattern. X with the same support as X, which means so 1 through 100 there is no superset. Okay, this is kind of the finite. Okay, closed item set. Okay, so for example, if we have the A1 through A50, it's also closed item. I got confused. Next pattern is the maximum. Okay, no frequent super pattern. Okay, that makes sense. And closed is the frequent, and there exists no super pattern that includes X with the same support as X. So why? This one is superset of pattern. I'm confused with the next pattern. Next pattern is definitely A1 through 800. Okay, it's a maximum. There is no super. So then closed pattern, closed item set used for the not the propagate to many. Okay, so this is kind of the closed minimum. Closed can understood as the minimum. Okay, minimum the item set. Okay, A1, A through the A50 is kind of minimal item set. Okay, that can represent. So 1 through 100. 1 through 100 is the minimal item set that can represent the one using A1 through A100. That is the minimal the item set that is called the closed item set. A1 through A50 is another the minimum item set that represent A1 through A50. Using A1 through A50, we can have the many other cases also. Okay, but so using A11, A22, something like that, but we do not consider such a thing. It's a kind of minimum the item set that can represent. A1 through 800 is the only one that can be represented by using A1 through A100. Okay, but this one is the only, the minimal item set can be represented by A1, A2 through A50. Using this 50, this is the only the minimal item set. So that is the reason we have only two closed item set. That is the definition of the closed X is a frequent. There exists no super pattern. Why? Okay, that is the with the same support as X. Okay, but maximum pattern is the maximum. So this include A1 through 50. So we can use the closed item set maximum pattern for frequent to find the association rule. Okay, we can minimize the item set case. We will see the example later to make the association rule mining efficient. I think I may be a little bit confused. I will explain. Because of Tylenol, I took the Tylenol just before started this class. I got cold yesterday, so I don't know. Right now, even I cannot hear what I'm saying sometimes. Since I may be confused, later I will clarify. But anyway, this is true. Closed item set is kind of minimal the item set to limit the extension of the item set. So we are going to address the problem of the computation. So how can we reduce the computation to find the frequent mining? We can, for example, use the closed item set and maximum pattern, or we can make a kind of index or something, the hash technique. So, but sometimes we may lose the accuracy of such a frequent item set, but we can get the speed of the performance of that. So, first we are going to start the traditional way of the frequent data mining. So that is called a priori. So a priori means previous. So based on the previous experience, we are going to decide the frequent set. So that is called a priori. A priori is proposed the first time by Dr. Aguilar. Okay, so there are two steps to find the frequent pattern. One is the joining. Another one is the pruning. Joining means we try to make all the combination first. Combination of the item from the start point. Then we are going to prune out. So if the item set is less than the minimum support, we remove. Such a case is a pruning. Then make another combination. At that time, we are going to start from the one item set first. Then second item set, third item set, and forever until the end of the maximum item set. Okay? The idea is that if for example, A, B, C item, there is a 3 item set. This is a frequent pattern. Obviously, automatically, A and B is a frequent pattern, right? Also, B and C is a frequent pattern. And C and A is a frequent pattern. So subset of frequent pattern is automatically frequent pattern. So we try to use that idea, which means we are starting from the one item set. Okay? Then find the prune out non-frequent item set. Then move to the next level item set. 3 item set, then 4 item set, 5 item set. So that is a priori. The reason, so based on the previous experience, we decide the next So that is reason it's called a priori. Okay. So we are going to use this database. So how many transactions? 4 transactions. How many items for the transaction ID 10? A, C, D, B, C, E, A, B, C, E, and B, E. We try to find the frequent pattern from this. We are going to start from the one item set. That is A, B, C, D, E. 5 of them, right? Then what is the support for A? 1, 2. B, 1, 2, 3, 3. C is 1, 2, 3, 3. D is 1. And E is 1, 2, 3. So first we can have the table, item set, one item set with the support. So our minimum support is set as the 2. So in other words, the less than 2, which means 1 will be pruned out. So we remove the D. Because the D happened only one time, any item set that include the D are not frequent pattern, right? Because D happened only one time. So any item set including D will not be the frequent item. Okay. So then next, join. How to join? Either we prune out. So first join and prune. Then the next level. Next level is the 2 item set. How can we make the 2 item set? All combination. A, B, A, C, A, E, B, C, B, E, C, E. How many? 6. We do not consider the order. C, E, and E, C are same. So we have the 6 of them. Then scan the database again. How many AB? 1. The transaction ID 30. And how many AC? 1, 2. 2. How many AE? 1, 2, and 1. Okay, so 30. How many BC? 1, 2, 20, 30, 2. How many BE? 1, 2, 3. So 3. How many CE? 1, 2. So we have such a table. Then prune out the item that has less than minimum support. That is AB and AE. So we have 1, 2, 3, 4 items. So then next, so we are going to join these 2, A, B, C. Then A, B, C, E is a 4 item set. So we do not consider. Okay? Then A, C, E. Okay? Then B, C, E. Then B, C, E also. Okay, then we have to count, if we count them, we have only B, C, E happen 2 times. Okay? So we actually remove because of the space, this part. So we have the BCE is bigger than, equal or bigger than minimum support. What about the next level? No, no more. This is a final. Okay? Because we have only the biggest item set that satisfies with the minimum support. So if we consider the 3 item set, we can take this one as the frequent item set. If we consider 2 item set plus 3 item set, we can consider also this one also. So that is one of the way to find the frequent. We do not consider support the confidence yet. Confidence will be used for generating rules from here. So, for example, from here, if we find the rule of this, the AC, when A is purchased, okay, when A is purchased, A is 2, then C are purchased. So confidence is 2, 100%. 2 out of 2. So if you set up the confidence as a 50%, then you can have the rules. When A is purchased, then B will be purchased. That is the rule. Okay? Don't be confused with the frequent item set with the rules. Rules is, as the name implies, it's a rule. So when A is purchased, then B will be purchased. How can we decide? With the confidence at the time. Okay, so this is the a priori algorithm to find the frequent item set. Okay, basically consists of the join and the pruning step. This is the pseudocode of that a priori algorithm. It's not very difficult to implement by yourself. Okay, it's based on the flow. You can start from the one item set, one frequent item set, then increase. Okay, inside the loop, so you can check. You can implement exactly the same thing as this one. How many of them I have? You should be you should recognize. You can see how many times full table scan. This time you need to full table scan 1 time, and 2 times, and 3 times. Every loop you need to scan full of your database. Do you think it's expensive or it's okay? It's very expensive. In case of the full, the transaction is okay. But what if you have the 10 millions of data? And also 10,000 items. You don't know how many times you need to loop. And for each the loop, you need to full table